Hi everyone, welcome back to chemistry. In this video, we're going to talk about mole relationships in chemical equations. So just like we can look at some kind of compound's formula and say how many moles of each individual atom is in 1 mole of that compound, we can also use balanced chemical equations to determine how many moles of each substance react with how many moles of another substance and how many moles they produce. So the key here is to make sure that your chemical equation is balanced before you try to figure out those mole to mole relationships, okay? And we'll talk more about what that means. So here we just have some solid iron reacting with solid sulfur to give us iron 3 sulfide. So looking at this equation closer, we can actually use the coefficients in front of each of our reactants and products to determine how many moles are reacting in this equation and how many moles are formed. So looking at these coefficients in front of our chemicals or in front of our species, we can see that we have 2 moles of iron reacting with 3 moles of sulfur to give 1 mole of iron 3 sulfide. So, and those numbers all came from the coefficient in front of our different reactants and products. So mole to mole factor is a ratio of the moles for any 2 substances in an equation. So in other words, how many moles of iron react with how many moles of sulfur in this equation. And then you can write that as, just like a conversion factor. You can write it with iron on top and sulfur on the bottom, or vice versa. And it's just that ratio of, hey, how many moles of iron react with how many moles of sulfur. And you can do that with any combination of these substances in your equation. So you can make a conversion factor from this balanced equation about, iron and sulfur. You can make conversion factors for Fe, comparing Fe and Fe2S3, right? You can look at one of your products and one of your reactants. In this case, we only have 1 product. Or you can do the other reactant and the product. And this is really useful. So again, just more conversion factors that we can use to solve equations in chemistry. So consider the following equation. We've got hydrogen in its elemental form, right? Hydrogen is a diatomic molecule, so we're going to see it in nature as H2. N2 is the same way, nitrogen. So we have hydrogen and nitrogen reacting to form NH3, ammonia. So looking at these coefficients here, we can say 3 moles of hydrogen are reacting with 1 mole of nitrogen to give us 2 moles of ammonia. So we want to know, what is the mole to mole factor for H2 and N2? What is one of the ones we could draw? I just think of this as a conversion factor, but you can think of it as a mole to mole factor as well. So if you said B, you would be correct. Why is it B? Well, in this chemical equation, we always have a ratio of 3 moles of hydrogen reacting with 1 mole of N2. And remember, I'm getting that from the coefficients, okay? All right, let's try this next one. So what about for NH3 and H2? Yeah, it's actually B again, because we have 2 moles of NH3 produced from 3 moles of hydrogen. Okay. All right, so let's try this on our own. So, how many moles of Fe2O3 can form from 6 moles of O2? So we're going to set this up just like we would a normal dimensional analysis problem. So I start with what I'm given, which is 6 moles of O2. And I want to find how many moles of Fe2O3 are formed from that many moles of oxygen. So we'll start with what we're given. So 6.0 moles of O2. And then we want to cancel out those moles of O2 and eventually end up in moles of not O2, but Fe2O3. So we need something that connects moles of oxygen to moles of Fe2O3. So what do we have? So let's just look at those two things. So we have, here's our oxygen, right? And here is our Fe2O3. So how many moles of oxygen are reacting to form how many moles of Fe2O3? Yeah, it's a 3-to-2 ratio. 3 moles of oxygen produces 2 moles of Fe2O3. So what goes on the top of our conversion factor? Well, we want to get to moles of Fe2O3, so that's going to go on top. What goes on top then? Is it 1 mole? No, it's going to be 2 moles, right? We gotta show what that mole to mole ratio is. So 2 moles of Fe2O3 per every 3 moles of O2. Okay, and I got those numbers from my coefficients in my balanced chemical equation. All right, so let's cancel these out. So we have our moles of O2 canceling out, and now we're left with moles of Fe2O3, which is exactly where we wanted to get to for our goal. And then just to save time, let's just go ahead and see what we get. Did we do that correctly? We did, and our answer is going to be 4 moles of Fe2O3. All right, try this one on your own. How many moles of iron are needed for the reaction of 12 moles of oxygen? So now we're looking at our, let's color code a little bit. We want to know how many moles of iron, and we know how many moles of O2. So we're looking at these two things. All right, so let's see. We're given 12.0 moles of O2, so we'll start with that. 12.0 moles oxygen. And we want to see how many moles of iron we can get out. Or sorry, how many moles of iron react with those 12 moles of oxygen. Okay, so moles of oxygen is going to go on the bottom, right? How many moles of oxygen? Yeah, 3. How did I get 3? I got it from our coefficient. Okay. And now how many moles of Fe react with 3 moles of oxygen? Yeah, 4. Yep, for every 4 moles of iron, I'm reacting 3 moles of oxygen to give 2 moles of Fe2O3, okay? Iron 2 oxide. Iron 3 oxide, sorry. All right, so again, to save time, let's just see what the answer is here. Yep, and it looks like 16.0 moles of iron. Okay, now, both of these examples already had balanced equations for you, okay? So we didn't have to balance the equation ourselves, but in the future, you are going to have to make sure if your equation is balanced before you start these problems, okay? So typically, you'll see them just with no numbers in front for their coefficients. And what you need to do is balance that equation first. So if you still need more practice with balancing chemical equations, I highly recommend you practice. Look at the book problems for balancing, which was section 7.1. But really all of chapter 7 has lots of good examples for balancing. So try those out, and if you need any more practice problems, I'm always happy to find some for you. Okay? All right, I'll see you in the next video.